Hello and welcome back to yet another episode of Software Engineering. Myself, Fazira Razak Hamza, PG Department of Computer Science, and I am here to present on the course Principles of Software Engineering. As I have stated in the last episode, the most widely used of all agile process models is extreme programming or XP. But many other agile process models have been proposed and are in use across the industry. Very common ones are Adaptive Software Development, ASD, Scrum, Dynamic Systems Development Method, DSDM, Feature Drive Development, FDD, Lean Software Development, LSD, Agile Modeling, AM, and Agile Unified Process, AUP. So today we're going to see all these agile process models in detail. Let's see each one in detail. The first agile process model, that is adaptive software development. It was proposed by Jim Highsmith as a technique for building complex software and systems. ASD focuses on human collaboration and team self-organization. He defines an ASD life cycle that incorporates three phases. First phase is speculation. During speculation, the project is initiated and adaptive cycle planning is conducted. Adaptive cycle planning uses project initiation information, that is, the customer's mission statement, project constraints, for example, delivery dates or user descriptions, and basic requirements like to define the set of release cycles, that is, software increments, that will be required for the project. Based on the information obtained at the completion of the first cycle, the plan is reviewed and adjusted so that planned work better fits the reality in which an ASD team is working. Second point, that is collaboration. This approach is a recurring theme in all agile models. It encompasses communication and teamwork along with individualism because individual creativity plays an important role in collaborative thinking. People working together must criticize without animosity, assist without resentment, work as hard as or harder than they do, have the skill set to contribute to work at hand, and communicate problems or concerns in a way that leads to effective plan. Our next phase is learning. It is important as the team progresses towards a complete cycle. Learning will help the team members to improve their level of real understanding. ASD teams learns in three ways. First, they focus on groups. Second, through technical reviews. And third, through project postmortems. So, this is the figure showing ASD. See, we have the first phase, that is known as speculation, which have adaptive cycle planning, uses mission statement, project constraints, basic requirements, and a time-boxed release plan. We have the second phase, that is collaboration, where we have requirements gathering, and we have JAD, JAD, that is Joint Application Development, which is a process used to collect business requirements while developing new information systems for a company. Then we have the phase learning, components implemented or tested, focus groups for feedback, formal technical reviews, and will conduct the project postmortems. Then we'll be releasing the software increments and will be adjustments for subsequent cycles. This is another figure which shows the three phases of AST. Now next model is Scrum. Okay, now let's see what is Scrum. It was conceived by Jeff Sutherland. Very different name, right? Scrum. The name is derived from an activity that occurs during a rugby match. Do you know what is a rugby match? This rugby matches are usually played in US states where they hardly run behind a ball to make it a goal. So here also the same thing happens in the project, used to guide development activities within a process that incorporates the following framework activities. Okay, it is an agile software development method that was conceived by Jeff Sutherland and his development teams in the early 1990s. So, Scrum principles are consistent with the Agile Manifesto and are used to guide development activities within a process that incorporates the following framework activities. Let's see what are they. First one, that is requirements, analysis, design, evolution, and delivery. Within each framework activity, work tasks occur within a process pattern called a sprint. The work conducted within a sprint is adapted to the problem at hand and is defined, often modified in real time by the Scrum team. So let's see what is sprint. I'll be explaining it in the next slide. Okay. So let's see the figure. So this is the figure. For Scrum, there will be a 15-minute daily meeting. Then team members responds to these three questions that is being listed there. Then every 24 hours, there will be a meeting. And every 30 days, after every 1 month, there will be a sprint that is being released. So let's see what is a backlog and a sprint. See, Scrum emphasizes the use of a set of software process patterns that have been proven effective for projects with tight timelines, changing requirements, and business criticality. The first development action, that is backlog. A prioritized list of project requirements or features that provide business value for the customer. Added to the backlog at any time. The product manager assesses the backlog and updates priorities as required. Then we have the next one, that is sprints. Consist of work units that are required to achieve a requirement defined in the backlog that must fit into a predefined time box, that is typically 30 days. Changes, for example, backlog work items are not introduced during the sprint. Hence, the sprint allows team members to work in a short-term but stable environment. Then we have Scrum meetings. I already discussed that we'll be having typically a 15-minute meetings held daily by the Scrum team. 3 quick questions are asked and answered by all the team members. So what are the three key questions? What did you do since the last team meeting? What obstacles are you encountering? What do you plan to accomplish by the next team meeting? Then we'll be having a team leader called a Scrum Master who leads the meeting and assesses the responses from each person. The Scrum meeting helps the team to uncover potential problems as early as possible. Daily meetings lead to knowledge socialization and thereby promote a self-organization team architecture. Then we have demos. Deliver the software increment to the customer so that functionality that has been implemented can be demonstrated and evaluated by the customer. Demo may not contain all planned functionality but contains functions that can be delivered within the time box that was established. Our next model is DSDM, that is Dynamic System Developments Method. It is an agile development software approach that provides a framework for building and maintaining systems which meet tight time constraints through the use of incremental prototyping in a controlled project environment. It follows the principle that 80% of an application can be delivered in 20% of time it would take to deliver the work, complete 100% application. DSDM is an iterative software process in which each iteration follows the 80% rule. That is, only enough work is required for each increment to facilitate movement to the next increment. The remaining detail can be completed later when more business requirements are known or changes have been requested and accommodated. We have a DSDM consortium, that is www.dsdm.org, is a worldwide group of member companies that collectively take on a role of keeper of the method. The consortium has defined an agile process model called the DSDM life cycle that defines 3 different iterative cycles, preceded by 2 additional life cycle activities. So now let's first see the first cycle, that is feasibility study. It establishes the basic business requirements and constraints associated with the application to be built and then assesses whether the application is a viable candidate for the process. Then we have business study, establishes the functional and information requirements that will allow the application to provide business value and also defines the basic application architecture and identifies the maintainability requirements for the application. Next cycle is functional model iteration, produces a set of incremental prototypes that demonstrates functionality for the customer. The intent during this iterative cycle is to gather additional requirements by collecting feedback from users as they exercise the prototype. Design and build iteration. It revisits prototypes built during functional model iteration to ensure that each has been engineered in a manner that will enable it to provide operational business values for end users. Then we have implementation, places the latest software increment into the operational environment. The increment may not be 100% complete or changes may not be requested as the increment is put into place. The DSDM development work continues by returning to the functional model iteration activity. Our next agile model is FDD, that is Feature Driven Development, a practical process model for object-oriented software engineering applied to moderately sized and larger software projects. Like other agile process models, FDD adopts a philosophy that emphasizes collaboration among people on an FDD team, manages problem and project complexity using feature-based decomposition followed by the integration of software increments. Communication of technical detail using verbal, graphical, and text-based means. In the context of FDD, a feature is a client-valued function that can be implemented in 2 weeks or less. Features are small blocks of deliverable functionality so that users can describe them more easily, understand how they relate to one another more readily, and provides a better review on errors. Operational features are delivered by the FDD team every 2 weeks. The following is the template for defining a feature. So you'll be having an action, result, then an object, where an object is a person, place, or thing, including roles, moments in time, or intervals of time, or catalog entry like descriptions. See, for example of features for an e-commerce application might be, we can add the product to shopping cart, that is a feature. Then display the technical specifications of a product and store the shipping information for the customer. FDD defines 6 milestones during the design and implementation of a feature, that is design walkthrough, design inspection, code inspection, and promote to build. FDD approach defines 5 collaborating framework activities, and these are called processes in FDD. They are, say, develop an overall model, build a features list, plan by feature, design by feature, and build by feature. Our next model is LSD, that is Lean Software Development. Lean software development has adapted the principles of lean manufacturing to the world of software engineering. The lean principles that inspire the LSD process can be summarized as: eliminate waste, that is adding no extraneous features or functions. Build quality in, that is assessing the cost and schedule impact of any newly requested requirement. Create knowledge means removing any superfluous process steps. Defer commitment means establishing mechanisms to improve the way team members find information. Deliver fast, that is ensuring the testing finds as many errors as possible. Respect people, that is reducing the time required to request and get a decision that affects the software or the process that is applied to create it. And last, optimize the whole, that is streamlining the manner in which information is transmitted to all stakeholders involved in the process. Our next model, that is Agile Modeling, AM. Agile modeling is a practice-based methodology for effective modeling and documentation of software-based systems. Is a collection of values, principles, and practices for modeling software that can be applied on a software development project in an effective and lightweight manner. The AM philosophy recognizes that an agile team must have the courage to make decisions that may cause it to reject a design and refactor. Modeling principle those that make AM unique are: first one, model with a purpose. A developer who uses AM should have a specific goal in mind before creating the model. Then use multiple models. AM suggests to provide insight on each model should present a different aspect of the system, and only those models that provide value to their intended audience should be used. Then travel light. A software engineering work proceeds keep only those models that will provide long-term value. So every work product that is kept must be maintained as changes occur. Then content is more important than representation. Modeling should impart information. Know the models and tools you use to create them. That is, understand the strengths and weaknesses of each model and the tools that are used to create it. Then, at last, adapt locally. The modeling approach should be adapted to the needs of the agile team. Our next model, that is Agile Unified Process, that is AUP. It adopts the classic UP phased activities, that is inception, elaboration, construction, and transition. AUP provides a serial overlay, that is a linear sequence of software engineering activities that enables a team to visualize the overall process flow for a software project. Within each of the activities, the team iterates to achieve agility and to deliver meaningful software increments to end users as rapidly as possible. Each AUP iteration addresses the following activities. First activity is modeling. UML representation, that is Unified Modeling Language representations of the business and problem domains, are created. Implementation. Models are translated into source code in implementation. Then testing. Like XP, the team designs and executes a series of tests to uncover errors and ensures that the source code meets its requirements. Then deployment focuses on the delivery of a software increment and the acquisition of feedback from end users. Then configuration and project management. Actually, configuration management addresses change management, risk management, and the control of any persistent work products that are produced by the team. Then project management tracks and controls the progress of the team and coordinates team activities. At last, we have environment management. It coordinates a process infrastructure that includes standards, tools, and other support technology available to the team. So these are the models in Agile software development. Thank you so much for listening.